This is the second half of lesson 13.3. In this lesson, we will learn how to calculate exact values for cosine and sine using the unit circle and radian measures. And we'll also learn how to find the length of an arc of a circle. Okay, first question, what are the exact values of cosine pi-4 radians? Pi-4 radians is right here. If you look on your unit circle for pi-4, you find the coordinates to that point are root 2 over 2 and root 2 over 2. Since we know that the first value is cosine and the second value is sine, then we know that the cosine of pi-4 radians is root 2 over 2 and the sine of pi-4 radians is root 2 over 2. In our second question, we're looking for 7/6 pi. So in the circle, 7/6 pi is 1 pi plus another 1/6 pi. So it's right about there. If you look on your unit circle for 7 pi 6, your coordinate here would be negative root 3 over 2 and negative 1/2. Since the first one is cosine and the second one is sine, then we can find that the cosine of 7 pi 6 is negative root 3 over 2, and the sine of 7 pi 6 is negative 1/2. You can find that right off your unit circle. Next, we're looking at finding the length of an intercepted arc. So if we have a circle with radius of r and a central angle theta, which is measured in radians, and this is very important, it has to be measured in radians. So if it's given to you in degrees, you need to convert it into radians. Then we can find the length S, the intercepted arc, the length S of the intercepted arc is found by this formula, S equals r theta. And this comes directly from the formula for the circumference of a circle. So let's look at an example. Suppose we have this circle and we want to find the arc length S. So using our formula, S equals r theta, the picture shows us the radius here is 3 inches. So S is equal to 3 times theta, which is the arc, 5 pi 6. So if we use our fraction knowledge, 3 goes into 6 2 times. So we get an arc length of 5 pi halves. You could put this in your calculator and get a value of 7.85. Okay, if we wanted to find the length of B, this other arc out here, if we want to know the length of B, we'd do the same thing. Using our formula, S equals r theta. R is still 3. This time theta is 2 pi thirds. So using our knowledge of fractions, we know the 3's will cancel, and we get 2 pi. If you calculate this, this gives you 3.14 times 2, which would be 6.28 inches. If the radius were doubled, how would the arc length change? So using our formula, S equals r theta, if the radius becomes twice as big, then the arc length would also become twice as big because instead of r being 3, it would be 6. So it just doubles everything. Okay, and then we can use this information to answer questions such as this one. A weather satellite in a circular orbit around Earth completes one orbit every 2 hours. So that means this satellite here goes all the way around the Earth in 2 hours. How far does it travel in 1 hour? Well, if it takes 2 hours to go all the way around, it's going halfway around in 1 hour. So, but what is that distance? So using our formula, S equals r theta, the radius for the satellite is from its point out here in space all the way to the center of the Earth. So the radius is 2,600 plus 6,400, which gives us 9,000. 9,000 kilometers. And then theta has to be measured in radians. Halfway around the Earth would be 1 radian, or 1 pi radians. So multiplying this together, we would have 9,000 times pi, which is 28,274 kilometers. So if we suppose that the satellite orbited 3,600 kilometers above Earth and completes an orbit once every 4 hours, how far would it go in 1 hour? Well, we know in 1 hour it would only travel 1/4 of the distance around, so theta would become pi halves. So using our formula again, we have S equals, the radius would now be 10,000 kilometers, the radius of the Earth plus out to the satellite, so 6,400 plus 3,600 is 10,000. Multiply that times pi halves, and we would get 5,000 pi, which we can convert into miles by just multiplying 5,000 times pi, and we get 15,708 kilometers in 1 hour. That's pretty fast. That's it for this lesson.